Hello, everybody. My name's Bernie Higgins. I'm a former firefighter from London Fire Brigade. I now run my own company and I work. One of the customers I have is Cold Cut Systems, and they will feature in this presentation today. I'm also a director of the Fire Industry Association, one of the largest trade associations in the world, based in the UK. We're going to look today at an emerging risk, the electric vehicle fires that appear to be occurring around the world. And we're going to look at the risks from these and some of the mitigation that we can use, and in particular in terms of firefighting. Cold Cut Systems, a company I work for, and they pride themselves on safer, cleaner and more efficient firefighting, about which more later. So the transition to alternative fuels and indeed electricity is going to bring new challenges for the fire services. I'm sure many of you will be aware that there's been a number of YouTube clips of car fires involving lithium-ion batteries, some of which look incredibly hard to put out. These are going to be a new challenge for the fire and rescue service, and we've seen the sales of electric vehicles go up, particularly in last year, 2022. We're likely to see that happen, that trend continue and grow, particularly as cities around the world begin to ban petrol and diesel cars and start to turn more to electric vehicles. I have to say from the outset, the likelihood of an electric vehicle fire is pretty low. They're safe and they're good. However, when they do get the fire, the consequences can be severe in a number of ways, not least of which is the disruption they bring if you have to close a road off, or more importantly, a motorway or a main arterial route into a city or a town. The economic consequences of having to shut off a major road are pretty severe. So we need to look at how we can deal with this quickly and efficiently. And of course, rescue personnel, if one of these cars involved in a road traffic collision, will face different risks and threats and require new methods. So we do need to know more about the risks. We do need to make sure that we're all acquainted with the risks. And we also need to know about how to handle an electric vehicle after a fire has occurred. So the risks, well, obviously there's a risk to nearby things catching light, particularly if the electric vehicle is in a car park or indeed is next to another car. The fire spread, particularly if the battery goes into thermal runaway, the fire spread can be quite quick and quite dramatic. There's also an explosion risk, or to be more precise, a detonation risk from the gases given off when a battery goes into thermal runaway. It can give off hydrogen cyanide, hydrogen gas, both of which have got very wide explosive range, and therefore there's a risk of detonation. There's also a risk from contaminants within the smoke itself. So that's a particular risk if the car is indoors, for example, or particularly for firefighters, responders and members of the public if they're close to that smoke and breathing it in. But of course also when the fire service arrive or responders arrive and start trying to fight the fire, some of those contaminants will find their way into water runoff. So therefore giving an environmental risk as well. And of course, as I've mentioned, there's the economic risk of having to close city centres or routes into city centres and town centres as a result of an electric vehicle fire. So you really do need to deal with these quickly and effectively and efficiently if you're to keep a town or city running well. Cold Cut Systems, we just talked about those, a little bit about those. We do believe in a world of safer, cleaner, and more efficient firefighting. Safer because you can firefight from outside a fire compartment. I'll talk a bit more about safety in relation to electric vehicles in a minute. Cleaner because it uses water mist and uses a lot less water. And more efficient, it can do a quick knockdown of the fire. This is what Cold Cut Systems does. That's a picture of their factory in Sweden, just outside Gothenburg. Sells and manufactures the Cobra, which is all it does. And it's a piece of equipment which is used worldwide, most of which the customers of which are fire and rescue services, but it has a range of uses. As you can see there, I'm not going to go through them all, but this isn't just a tool which is for use on lithium-ion batteries or for electric vehicles. It can also be used in a range of other circumstances as well. So, as I said earlier, it allows firefighters to cool hot fire gases from a safer position outside the fire compartment. You can see a firefighter there operating the equipment, simply uses an abrasive in the early stages to pierce a material, and it will pierce metals, so car bodies, very quickly. It will pierce all known building materials. Sometimes it takes up to a minute or more, depending on the thickness of the material, but in general, around about 30 seconds will do it. Ultra high pressure water jet combined with abrasive quickly pierces. There's a very small hole and no extra oxygen is admitted to the fire, particularly for fire compartments. The water then comes out in a very fine mist. It's about a 10-metre throw, large effective surface area on the droplets of the mist, and that allows fire gases to cool. As we'll see, that's not quite so relevant for batteries. However, it still has that very effective cooling. So where you haven't got perhaps hydrant supplies and good firefighting water supplies, having a tank full of water, 60 litres a minute, will give you a reasonable time. Just from a standard Type B fire appliance water tank will give you quite a significant amount of firefighting time. This is the Cobra method, and this is relevant for fighting electric vehicle fires. We look at scanning using a thermal image camera, and that's to identify the hotspots and where the best place is to sight the Cobra to use it. Attacking, which is basically sighting, piercing, getting into, and then using the water mist. Ventilating, again, very important for electric vehicle fires because particularly indoors, where you can ventilate and dilute the gases and take them out of their flammable and explosive range. And then, of course, if it's a fire compartment, you can enter with an electric vehicle, of course, if you've managed to cool the battery and prevent further thermal runaway and propagation, then you can start to open up the car itself. So, looking at the car batteries, we know we have a proven method here to stop propagation. I will talk about the tests which enable us to say that in just a moment. But firefighters do need a safe and effective way to attack these incidents from a reasonable range, and that involves a slightly longer lance on the Cobra than you would previously have seen. We know that the best way, and at the moment, as far as we're aware, the only way to stop a vehicle lithium-ion battery is to get water inside that battery pack. Try and get water within the cells, and that's the way you cool them down and actually deal with thermal runaway and indeed prevent further propagation. There are a number of methods for fighting these fires, but the hardest bit is getting the water inside the cells. And this is, of course, made much harder if the vehicle itself has been involved in a road traffic collision and therefore is misshapen, and it's difficult to get access to the battery or indeed the underside of the car to get to the battery. So we use Cobra as a tool that can be used from a variety of places because we know it will pierce both the car outer shell and the bodywork and pierce into the battery itself. So it overcomes some of those issues. A number of tests have been carried out abroad, overseas, on battery packs, both on battery packs themselves and indeed on full-size electric vehicles. And we've proved that we can stop propagation simply by using Cobra to get inside that battery pack and internally cool the car and the battery. We've done more than 20 tests and they've all indicated exactly the same conclusion. The key point really here is that actually Cobra doesn't just put it out the car, the battery stays out. It prevents further propagation, and actually the battery is then fully extinguished. We have seen cases, and it's a bit hit and miss this with cases, but there have been cases where the car itself has been completely immersed in a tank full of water to try and cool the whole car and the battery, and it's been left there for a couple of days, and as soon as it's brought out and dries out, propagation begins again and then goes back into thermal runaway, which has caused some problems for those people who have to remove the car away from the roadside. And indeed, we've had subsequent fires in car pounds where the vehicle that's had a fire has been taken to before it's been scrapped, and the car is actually reignited there. We believe by using Cobra, that risk of further reignition once it seems that the car is out actually is mitigated and there is no further reignition. And some of the tests we did show that there was no reignition by just agitating the battery pack and by making sure that we tested it every day to see if we could get it back into thermal runaway, and we couldn't. So there was a project in 2021, the Swedish Civil Contingencies Agency, also known as MSB, initiated a project to look at this very risk of electric vehicles. A broad expertise within that project, with local fire services and some consultants as well as scientific expertise to try and understand what the effect was and how this all worked. The project itself was to find and communicate a method for extinguishing fires in electric vehicles, also to make sure we fully understood all the risks and explain propagation, with the aim of spreading knowledge and creating security. It's worth pausing for a second to look at risks. A car fire, electric vehicle fire outside on the road will cause issues. You have to shut the road or indeed shut down part or all of a town or city centre, depending on where the electric vehicle is when it catches fire and goes into thermal runaway. Actually, if indoors can present very different risks. One, because there's a greater risk of detonation and explosion from the collecting fire gases, which will be within their flammable and explosive range, but also because there'll be other cars potentially parked nearby, particularly in, for example, an underground car park. And for some of these risks, you may need other equipment as well, such as the full car blanket or other methods for keeping the cars nearby cool while you deal with the car that's alight. I don't cover those too much in this presentation, but you should certainly be considering not just the electric vehicle fire itself, but also the different locations that such an event can occur, and having in place means for controlling both the risk from the car itself and, of course, the spread of fire. So looking at the tests, we had 4 modules of sub-packs, so smaller battery packs. We had a full battery pack, a full 24 modules, and a full-scale electric vehicle, the whole lot, 27 modules with the outside vehicle around the battery itself. And the questions we were asking, or MSB were asking, were, is it possible to stop propagation of thermal runaway in a burning lithium-ion battery pack? And can we learn and observe things to predict the fire dynamics? So we're going to cut straight to the full-scale electric vehicle with all 27 modules. You can see still here from using the thermal image camera, you can see the firefighter at the rear of the two has got a thermal image camera and is looking for hotspots and directing the firefighter with the ultra-high pressure lance, the Cobra lance, to direct it in the correct place to cool the battery and try and actually pinpoint down into which cells are actually in thermal runaway, because they'll give off a heat signature. This is quite important actually, because if you just go straight into the battery anywhere, you can actually set further cells off which into thermal runaway, which you don't mean to in the initial stages. So we try to look and be as accurate as possible with Cobra, and that's possible using the thermal image camera to identify the hotspots within the battery area, and then focusing piercing and Cobra cooling effect in those cells. You can see the firefighter at the front. You can see they're both wearing breathing apparatus, again, to mitigate that risk from the toxic contaminants, and also potentially from any deflagration or detonation, rather, of the fire gases. And you can see also there's an extra long lance there, which gives the operator just a little bit more space away from the area of greatest risk. But we saw that extinguishing was initiated after 15 minutes in all of these tests. Now, that was to simulate the response. A fire service generally, unless on the odd occasion you're very lucky, there won't be a fire appliance or a fire service nearby when an electric vehicle catches fire. So we had to simulate the fire starting and then 15 minutes as an average response time to give time for people to make the call, process the call, get the crew there. So we felt that 15 minutes would be a reasonable time, and that by which time the battery was in thermal runaway. And then when we arrived, we used Cobra together with the thermal image camera and a fan, and we used a normal firefighting branch as well, which I'll come on to in a minute, which was used for safe and efficient operation of all the equipment. Looking at the results, this is the really interesting part. If you look at all 27 modules, if you look purely at the ones with the red writing and the ones on the diagram in front of you, you can see they're in red. You can actually see that where those were the cells that went into thermal runaway that actually caught light. And those were the ones where we used Cobra and actually managed to cool and discharge the electric current. So they went down to 0 volts. And you can see in all of the other cells that to a larger or lesser extent, for example, cell 1 still had 15 volts, and many of them did. Cell 22, which was adjacent to a cell where we used Cobra, had only 3 volts of charge left. So you can see that Cobra wasn't used indiscriminately. It was used very carefully and dealt with those cells that were in thermal runaway, but left untouched a number of cells that weren't actually affected by thermal runaway. So going back to the motto, safer, cleaner and more efficient. If you use the right risk assessment and training, Cobra is very safe to use on electric vehicle fires. The electric safety risks are minimal because it's not a closed circuit, it's an open circuit, and firefighters are earthed with their rubber boots, etc. So there's little risk of any electric shock or shock risk. There's electric safety risks are minimised. Cobra itself uses a very low water flow, and in fact we found when we dealt with the full electric vehicle fire that actually we only use Cobra for 5 minutes, which is around about 30 litres of water 300 litres, sorry, of water in total at 60 litres a minute. We also used the normal firefighting equipment just to put out the rest of the car. So, and that was slightly longer. That was another 5 minutes. Sorry, same time, about 5 minutes or so, but used at 450 litres a minute. And that's very much the method. So you use normal firefighting, traditional firefighting methods to deal with the rest of the car, which just then leaves you with the battery to deal with. That's so that you can use the thermal image camera to really, really good effect to see exactly which cells are in thermal runaway and deal with those. So Cobra is safer, it's cleaner and more efficient because it quickly gets water into the battery itself, and that efficient cooling can stop propagation and further thermal runaway. And as I said to you earlier, actually it prevents that from reoccurring after the fire service had left. So the likelihood of reignition is significantly lower if you use Cobra. There you can see the full method. You can see, if you look at the firefighter at the very back with the white helmet with the red on it, you can see they've got a hose reel. So they've been dealing with the main fire and just dealing with that. keeping that cool. You can also see the firefighter with a thermal image camera, and just behind that firefighter is a battery operated PPV fan, which again is useful for directing the toxic contaminants and the smoke away from the firefighters and out of the way. It's particularly useful if if the fire has occurred indoors or in a car park in an enclosed space, because it can actually dilute, as I said earlier, the gases and reduce them down from underneath their detonation range or flammable range. And then you can see, of course, the firefighter at the front using Cobra as guided by the firefighter behind with the thermal image camera and directing that water mist into the right parts of the battery. As you can see, they're all wearing breathing apparatus, and breathing apparatus is essential for all car fires, but especially with electric vehicles, again, because of that toxic risk. So there we have the applied method. If I direct your vision to the right of this with the diagram, you have a confirmed electric vehicle fire. The next thing you need to know is the traction battery involved? So you need to identify it's an electric vehicle. Is the battery involved? If it's not, great, conventional methods are just fine, and ensure that extinguishing is the best approach. If it is involved, then you need to look at trying to extinguish the main part of the fire, as I said, and then using the thermal image camera and Cobra to really get into that battery and get water into the affected cells as quickly as possible. If the car is in the middle of a field or is well out of the way and you feel there's no surrounding risk to that, then it may be more optimal rather, to let the vehicle burn and just protect the surrounding area, and make sure the fire doesn't spread to other vegetation or other parts of the area. That's in those rare cases where the vehicle is somewhere completely remote, there's no fire risk around them and no further risk to the public. If there is that risk, or if there is a likelihood that the fire is going to spread, or we need to put that fire out because we've had to shut the road or a motorway, then use Cobra, as we said, using the thermal image camera and fan as well. So that's really the approach. And we're very clear about doing that risk assessment on arrival, seeing what's actually alight, the location of where it's alight, and then picking the right method, of which Cobra can be very, very useful if it's a car in those circumstances where the fire is likely to spread and the battery has gone into either thermal propagation or thermal runaway. And you can see that you need 3 people to make this work effectively and efficiently. You need a thermal image camera operator or TIC operator. You need someone with the Cobra operator, and then you need someone with the firefighting branch. And Cobra actually do make what they call a multi-purpose nozzle, and you can see the firefighter here using that multi-purpose nozzle to put the rest of the car out before we get to use the Cobra, just so that, again, as I say, you can see very clearly where the battery's gone into thermal runaway or not, and then you can use Cobra to deal with that thermal runaway. You must make sure you've got adequate personal protection and respiratory protection, both of which are absolutely essential requirements. And we'd recommend forced ventilation or positive pressure ventilation to establish a really good and safe working environment. Using that thermal image camera, again, look for hotspots, use the Cobra attack at the hotspot, and make sure you're establishing a good internal water flow into the cells that are affected. And don't be afraid, although we used it for only 5 minutes, if you think you need longer, use those thermal image camera readings to decide when you need to stop using Cobra because you've cooled the battery sufficiently. End that Cobra attack when the thermal image camera reads less than 50 degrees centigrade, and then just keep monitoring for around about 15 minutes as a minimum, potentially more. And if you've got any concerns or you feel that the hotspots are beginning to grow or the temperature on the thermal image camera is beginning to rise, then just put Cobra back in, into those hotspots, into those cells that are showing signs of propagation or thermal runaway, and Cobra will deal with those. If there are any remaining hotspots on the rest of the car, they can be dealt with using the firefighting branch, in this case, the multi-purpose nozzle. So as you can see from the screen and the writing, Cobra can be used on other forms of alternative energy, particularly the batteries, the bikes, and indeed solar panels. We also have an academy, which is set up to provide Cobra training. And if you're interested, we can provide, if you're already an existing Cobra user, we will have a training package ready to go within the next few months. But please do contact us for more information. As I said earlier, just to recap, it's a multi-dimensional tool, 360-degree capability, can be used all around the car, anywhere you need to, quick results, ergonomic, limits water damage, and very dynamic in use. And of course, it has that wide range of potential areas of use. Thank you very much. Been really good to talk to you all. I'm grateful for the invite. Thank you to Fire-by-Alive for inviting me to speak. I hope you found it of use. My contact details and contact details for Cobra are on the screen. Thank you.
So thank you, Bernie, for another great session. This is the second time you've actually spoken at Fire-by-Alive, the first in collaboration with the IFE, which can be found on our on-demand section on the platform, and this time on the hot topic of the adoption of electric vehicles. So tell me, Bernie, why Fire-by-Alive?
Two reasons, actually, Rebecca. And first, thank you for inviting me back. You reach a very wide audience, and our why, and my personal why as well, is about public and responder safety. If we can make responders safer in what they do, we can actually enhance public safety. So getting that message out to a widest possible audience is really important. And actually, Fire-by does reach a very, very wide audience. So hence, I'm a big fan, and hence why I'm back here again, doing it again.
Thank you. We appreciate that. So aside from the fire risk that electric vehicles pose, do you think we'll start to see an adoption of electric firefighting vehicles?
I think that's definitely on the cards, Rebecca. I believe there are prototypes in a couple of UK fire and rescue services. I believe London are testing a prototype electric pump right now. I believe Surrey have done the same, and I expect that to catch on as the desire to be more environmentally friendly takes a hold. Whether they'll all be lithium battery or not, I guess depends on what technology is available. I suspect there will be other means of powering larger vehicles and lorries and fire engines. The issue they have at the moment is having enough power both to get them to the incident, but also to run the fire pump, which I suspect at the moment will probably still have to be diesel or petrol driven. However, I'm sure that technological advances will allow a fully electric or alternatively powered vehicle in the future, and I certainly hope so.
Anyway, Bernie, thank you so much for your time. We really appreciate it. And if anybody would like to ask Bernie further questions, please do reach out to him on the platform.